Hi everyone, this is Spring. Yeah, I'm from Evo Conversion System out of USA. And today I want to bring you on the introduction of the roadmap I draw for the black solar industry, and trying to also point out a few points to indicate what's the relationship or where we are in the research field. Um, so this would be the map that I draw. It is what we think that covers everything um, on such a system. I will break it down in the piece so you can so you can see more clearly. So let me go over uh, in some detail. So for those who don't know what BSF can do, I mean there's a or in real applications. So we work in a way that we work with multiple, I mean, we work with a lot of companies in different parts of the world to put BSF um, into applications to treat waste. Um, just like David pointed out, I mean, the waste that there's a certain waste there's a lot of different kind of waste that everyone is using. Some are not legal in a local situation, but we deal with we have worked with a lot of kind of ways, and today I'm going to bring some example on the typical ways that we work in Asian market. That's the restaurant waste that comes from after, that's the post-consumer waste. Um, and in such a system, the trucks are sent to collect those waste. And after bringing back that in the major waste management technology in China, it's biogas. So the biogas, when we receive the waste, we work with the biogas facility, and the biogas facility, they have all the preparation equipments in place. So they receive the waste, they separate the waste into four major content. That's oil, water, solids, and contaminant. So the oil will goes to the biodiesel. That counts about 3 to 5% of the total biomass collected, and the water is the major part. It counts about 80% in 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 our situation, and the solids, it's normally about 10 to 15%, and that's not absolute solid. That's about 15%. Uh, that's about 70% moisture that's ready to be fed with the BSF. And the liquid goes into biogas, and the remaining um, the solids will be cooked, and then we collect it at the after it got centrifuged to get the oils out. And it looks like this when we receive it. We go through another round of fermentations to make a buffer. Um, and and then sometime after fermentation, the waste will be separated into different phases. And this we're going through a mixing, or we call it a water adjustment phase. That if it's too wet, we add some dry material. If it's too dry, we need to add some liquid to adjust it to the uh, right textures. Uh, and then we also work with so this is the machine that pumps the sludge into the bioconversion pan.
Excuse me, Spring, just a question. Sorry if I interrupt you, but
Yeah.
watching the presentation, I don't know if I missed it, but is this organic waste a source separated,
It's
or
not.
is it?
It's a source separated by the waste is only from the restaurants,
Oh, I see. I see. Thank
right?
you.
It
Oh,
doesn't have a lot of separations, so that's still a
oh.
huge load of separating
But
work
it's
at the factories.
just separate food waste.
Yeah, separate food waste. Yes.
Okay. Excuse me.
Yeah. Thanks for clearing it. Um. Uh. And the fee will allow feeding for 7 days. They go to So the paste would be dried down, the water evaporated, and the lava got harvested. The lava it's grown up after 7 days, and then going through a separating procedure, that's unloading uh, and uh, and a drum sifter. We use a lot of drum sifter, and the lava will be processed. In this case, on this presentation, I want to show you the microwave that's being used a lot in the Asian market. So the live lava goes into one end, and then the dry lava comes out the other end. Well, I know it's not quite legal, yeah, in the under the European regulation, but this just show you um, how we does that work. And this is the video taken at the commissioning stage. Um, so on the so that's one applications on how the BSF can help transforming the waste. I mean, it's not the dream that this can be taken in a much larger scale, but to go to the next stage, we there's so many things that we need to figure out. Like David said, we are still just scratching the surface, and by uh, wanting to go over the next level, we have to know what the what are the questions that we need to address, and identifying those questions would be helpful for us to understand. So we make the map to understand. I mean, what it takes to get to what kind of results, and this particle is on the biological side. That's what it takes to get the sea lava. The sea lava will be what you start rearing in your facility, and we trace it back. So it takes the appropriate light, the appropriate uh, uh, interior, and then egg trap and some nutrient supply. Then you can get the eggs with a healthy pupa, and it goes to a nursery, and in the nursery there will be a couple quality check, quality assurance steps, such as um, check the size consistency, ensure the age of the lava, and and also at this step we need to quantify the lava and to give a set amount of the sea lava that we would use to treat a certain amount of the waste. And on the other side will be the feedstock. So tracing whatever you use at the end is gonna be in the more or less similar textures. So if you go from this way and you trace it all the way down here, that no matter what you feed, there's a lot of feed sources that you can use. Uh, um, and in order to get them to the to readily feed feedstock, that you we need to there will be a few steps, such as fermentation and processing, some adjustment on the structure of the feed stuff, and adjusting the water content. So there will be some technical points that need to pay attention between the waste collected to when the feed are ready to feed the lava. Um, and after biodigestion, there will be uh, then it can the lava it's a major product out of the biological process, and then it can be processed into many different products. Depends on what kind of market that you have access to. So across the world that we have seen different kind of ways to make the products. Even just on the oven dry, depends on what kind of oven that you use and what kind of protocol you take. The appearance and the nutrient content it's a little bit different. And there's some for the pet market that it can make into a can, and for the agriculture, you can. So these are for the agriculture. Um, but the meal And the oil or the chitin, I mean, we haven't done a lot on those, but we have seen um, a lot of companies that's developing this in a very sophisticated technology. Um, and so far that we only know that the fresh can be used as a plant fertilizer, but this area has a very limited research on. So not many information on um, how to use the fresh and under what kind of conditions, because whatever the fresh quality is highly dependent on what is being fed to the larva. And so in the application that we need to do a lot of local, we call it data localizations. I mean, when we receive a protocol and then wanting to implement in the new location, I mean, the only way that you can check if this product actually fits into this market is to do the test again. But this kind of information is very limited. Um, and all the way down by the principle, the BSF has a huge potential because it's such an easy process. All it takes is collecting, it's putting X amount of sea larva and Y amount of feedstock into a pan, and then just wait a few days, and then it comes out to two valuable products. Um, but within this map, um, that's a lot of knots. So each image or each text here, it's a technic it's a technical knot that someone uh I should say, I mean, one factory should only pick one row on this map. For example, I mean, we always start with the on the market side, because you're producing a product that you want to sell into the market. So depends on what kind of market you have access to. Then this is just the ways that we know, we are aware how to make the product. But if you have something else that you would check from the ice block, and it goes out to determine the size of the lava, and then come in to determine the size of the bioconversion pan, um, and it and then it determines and then it goes back to determining how many lava you need to put into the pan and how many feedstock you need to put in the pan. And that gets it into the next topic. It's about that's one example that um, to show the complicated of the the system. So we conduct experiment that would be just testing on different sizes of the pan had what kind of effect it had on the lava. Um, the rationale is that the previous studies on the development of the BSF were mostly done on the benchtop scale. I mean, a lot of experiment on the publication side, it's into 300 milliliter containers. But in most of the industrial application, the container are at least 30 to 100 times larger. So we questioned, are the data from those research applicable on the large scale? Um, and the experiment that we did is that we just compared two of the we just raised the lava on two different sides of the container. Due to the time, I just briefing this design, but it's a very straightforward, just comparing different size. Um, we hatch the eggs, we grow it into grow it into the 5-day old, and then we prepare the feed into a standard tray. This is a 40 by 70 centimeters tray, and we inoculate the larva, and proportionally we reduce the feed and put it into the small container as well as the larva, um, and grow the larva out, uh, and then separate them. Um, and we measure the larva weight, the larval survivalship, and the mass conversion rate. So just by this simple just by this simple experiment that we learned that the size of the container had a significant impact on the larval, the mean larval weight, and the survivalship of the larva, and also the larval mass of the conversion rate. Then, knowing this different, that we know that a lot of research that's done in the past are not applicable on the large scale, and it takes a long it would take a lot more effort to determine the optimal conditions for raising insects in a larger scale. Uh, the some different point is that in the industry that we see a lot of times that the substrate, because it's in a better insulated area, and a lot of feed, that it can compost and heat up the substrate. So 45 degree is a normal temperature that we see in the larger scale, but in the lab scale, that because the container is so small, that it's always equal to it's almost equal to the ambient temperature. So this kind of microenvironments, microhabitat, it means very different than in the larger scale versus the benchtop scale. And even small differences would account for very large economic consequences. Um, so, and our experiment only did on this way, but the next step would be determine what would be the best size pens for raising the BSF, knowing that there would be the size plays a difference, right? However, um, this would be this would be a main challenge by itself, because everyone where I've traveled, uh, our team travel a lot to visit different facilities, and this is what I travel, just my personal travel, to see different BSF farms in the past 2 years. And we also see, one major challenge that we see is that people are all using different kind of size of the pens. So this pen size by itself is a huge topic that the industry somehow need to come up to a more or less agreement on a similar size. Otherwise, um, I'll show you. So there will be a few principal sizes. The smaller size pens, the medium size pen, that will be 1 by 2 meters, within that criteria, and different structures. Larger pens, we also see giant pens that made by steels, 3 by 6 meters, or the cement pounds, or racing on a conveyor belt, that kind of stuff. But this plays a huge difference on the growing protocols on the larva, and also affect the quality of the insect. Uh, for example, this one would be.
Excuse me, excuse me, Spring. Could you uh, go to the end of your presentation, because we'd like to keep some time for
Yes,
questions. So
this is the last one.
coming. Okay, excellent.
Yes. Yeah. The I bring the conclusion now. That's the BSF industry is a complex network with involving multidisciplinary knowledge. So we 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 just learned that we cannot do all this, make the answers to every question by ourselves. So we ask for um, collaborations, to fill in the information on those maps, um, and so that to bring the system a more complete system, or more perfect, that will benefit everyone. Um, Thanks everyone. That's my presentation.